Hey, what's up guys? It's Julia, and today I'm feeling pretty bougie today, so let's do some organic chemistry. Oh yeah, okay. Let's put her name down. Julia. There we go. Bada bing, bada boom. Let's get down to it. So which formula represents an alkane? Cane in the membrane? Oh, that is a single bond. So that's a single bond. So which here has a single bond? Oh, wait, no. If we look at our choices here, let's go to some special tables. That table is going to be, where is it? There we go. If you head on over to table Q, this gives us some beautiful formulas. So it's asking us which formula represents an alkane. If we notice this formula of alkanes, it's CnH2n plus 2. Cn, let's just write that down, CnH2n plus 2. So, let's use this formula and figure out what the hell choice answer is an alkane. So C2H2, no, that doesn't make sense. If we do C2, 2 times 2 is 4, plus 2 is 6. Number 2 does not make sense. Oh, let's put that into focus. C3 and H4. 3, 2 times 3 is 6, plus 2 is 8. No, that does not go up. But if we do 4, C3, H, 2 times 3 is 6, plus 2 is 8. Bada bing, bada boom, it's number 4. So which compound is an alkyne? When we think of alkyne, we think of 3 bonds. And let's go refer back to our alkyne equation in table Q. We have CnH2n minus 2. And let's just see which formula correlates with the equation, or whatever. We have C2. If we do 2 times 2 is 4, minus 2, we get 2. So number 1 can be a potential. I'm not going to bubble it all in. We got to check the other ones. So we have C2. We have 2 times 2 is 4, minus 2. No, number 2 does not go along. 4, 2 times 4 is 8. 8 minus 2 is 6. Number 3, no show. C4, 2 times 4 is 8, minus 2 is 6. So no. So number 1 is our answer. Number 3. Which atoms can bond with each other to form chains, rings, or networks? Carbon atoms. Carbon is this special guy. Always choose carbon when you're asked in pretty much any organic chemistry class. Or test, I meant. Number 4, the 3 isomers of pentane have different isomers. What are isomers? Basically, they have the same components, okay? What's different is their structure, okay? So they're gonna look a little funky, but all of this stuff is gonna be the same. That's gonna be constant. So 4 is gonna be 4. 5. Hydrocarbons are compounds that contain carbon only, carbon and hydrogen only, carbon, hydrogen, and oxygen only, or carbon. Okay, hydrocarbons is going to have carbon and hydrogen only, because they're special. I mean, if you notice table Q right there, I mean, it's only H and C's, so. The molecular formula of glucose is C6H12O6. What is the empirical formula of glucose? Whoa, those voice cracks. Empirical, we're thinking about, this is going to be a basic, I like to think of this as being the basic bitch. So empirical and molecular is complex, so we know this is basic. So let's make this basic. So we have 6 goes along with all it. So 6 divided by 6 is 1. 12 divided by 6 is 2. And divided by 6, that's going to be 1 again. So we're going to choose 6 and 2. Which pair consists of a molecular formula and its corresponding empirical formulas? Basically, it's going to be paired up with the basic formula and the non-basic or complex formula. So, C2H2 and then CH3. No, that does not go together. C6H6 and then 2. no, that would actually be if that was a molecular and this is the empirical would be just C and H. P4 and O10, you get 2 and 5, so okay, so 4 divided by 2 is 2, and 10 divided by 2 is 5. Okay, that seems pretty basic. I like it. I'm gonna circle it. Then SO2 and SO3, those look like both empirical formulas, so we're gonna fully just bubble in a 3, and that's correct. The relatively high boiling point of water is due to water having hydrogen bonding, 2, metallic bonding, 3, nonpolar covalent bonding, or strong ionic bonding. Okay, if you guys all of a sudden blinked out on what the hell hydrogen bonding is, these 3 answers, they're like totally false regarding water. I mean, metallic bonding, there's no metal in water. Nonpolar covalent bonding, we know water is like the most polar bitch out there. And strong ionic bonding, it's covalent. So number 1, we get hydrogen bonding. Okay. Number 9, it says, which substance in the table below has the strongest intermolecular forces? Ooh, okay, let's compare everywhere. Explain your answer using evidence from the table. When we think of strong intermolecular forces, it's going to have a high boiling point because it's going to take more energy to break those freaking bonds. So, let's just see which has the highest boiling point, and that's HF. HF. Because it has a mother trucking high boiling point. Okay. Base your answer to question 10 in the info below and on your knowledge of chemistry. The formulas for 2 compounds are shown below. Okay, we got compound A, compound B. Before I read this question, I'm just going to look at it. Let's compare it. Okay, so this is basic. This is not really basic. So here we have some double bonds going on here. We have this little carboxyl group going on. Let's see. So if we just refer, quickly refer, check up table R, we have the COO. This is an organic acid. Yeah. So 10, explain in terms of bonding why compound A is saturated. Okay, well, compound A is saturated is because there are single bonds. So compound A is saturated because there are single bonds. And if you want to go into more detail, of course, there are single bonds because that is like so much the single bond can carry. Let's just keep it simple and say there are single bonds. Anyways. Number 11. Okay. Topic 2. Organic functional groups. Okay. Which class of compounds contains at least one element from group 17 of the periodic table? Okay. So we have aldehyde. Just go to table R and we can see. An aldehyde, what's that made out of? Okay, we have C, O, and H. Okay. Oxygen. Let's just check up our periodic table. So it's talking about group 17. This is group 17, okay? We have fluorine, chlorine, bromine, iodine, and us. Okay. So aldehydes, they have C, O, and H. Oxygen is not in group 17. Let's just write what the aldehyde looks like, so we're more familiar with it on the test. So, hell no, bitch. And amine, okay, that has nitrogen in it. I don't think nitrogen is in group 17. See, nitrogen is not here. So, nope. And ester, okay, COO. Well, we just talked about how there's no oxygen. Let's look what halidide is. Oh, halidide. Yes, all of these. Number 4. The functional group COO is found in organic acids. Remember, this is probably going to be a super easy test for y'all because everything is literally in the reference table. Just match it up, play your match game, and then you're good, you're fine. So 13, given the 3 organic structural formulas shown below, which organic compound classes are represented by these structural formulas as shown from left to right? Okay, so this is a ketone automatically because a ketone literally looks like that. You just play match. Ketone, so cross out 1 and 2. Next we have a cuckoo. That's going to be organic acid. So cross out those 3. And here we have OH. That's going to be some booze or alcohol because we're bougie. So this is going to be 4. 14. The organic compound represented by the condensed structural formula CH3, CHO is classified as an I see some H and O. That's some alcohol right down there. Oh no, wait. Oh, this is some trickiness. We see this. If we look at the aldehyde, it can either be alcohol or aldehyde. Not so much ester, nor ether. We have an H and an O. Alcohol or an aldehyde right down here. The difference between with an aldehyde, this is what an aldehyde looks like. Let's move this up. Looks like that. And an alcohol looks like that. So let's just draw this out. If H see, and now we have an H. So this to me looks like it's gonna have to be a double bond with O and an H here. Because it wouldn't make sense if it was an alcohol with only an OH, because we would have to fill this all up. So this is 14 is gonna be number 2. Next up, number 15. Given the structural formula, the compound represented by this formula can be classified as an... Okay, so I see that middle O right there, and that's probably going to be an ether because if we play matchy, ether's right over here, and that looks exactly like that. So 15 is number 2. 16. Given the structural formula, we have... Oh, okay, so we have NH2. This compound is classified as an... Well, if I see some NH2 right over here, it's probably going to be an amide. An amide. Or amide. I don't know how to pronounce things. So given number 17. Oh, there we go. Given the formula representing a compound, what is the IUPAC name for this compound? Okay, so we have a ketone in here. So it's probably going to be, if we look at the ketone, it'll tell us pretty much how to write this out. So which branch? Okay, so this is the 3rd branch if we count from here. This is going to be 3, let's see how many total carbons we have. 1, 2, 3, 4, 5, 6, 3 hexanone. You know, the best thing about using this reference table is for labeling IUPAC names is it gives you an example of what the name is supposed to be like. So if we have 2-pentanone right here as this example, it tells us that, okay, we need to list out the branch number of where it is and just the number of carbons and have the known at the end. While in, this one for ether, we have methyl ethyl ether. It just tells us how to kind of write it out. Number 18. Which compound is an isomer? Isomer, basically, it has different structures, but same composition. So basically, let's just figure out, you know, if this has the same number of content as this. So C2H5, we have C2, okay. No, this doesn't look right. So I don't think it's number 2. Let's see. We need to find 2 carbons. Okay, 1, 2. There are 2 carbons. We need 10 hydrogens total. There's no 10 hydrogens here. Okay, we have total. We need to get 4. Okay, we have 4 carbons. We need 10 hydrogens. 7 plus 3, that's 10. And we need just 1 oxygen. Yeah, so 18 is going to be 3. Oh, wait, no. Did I count incorrectly? So let's just write out a list. We have CO4. We have 10 hydrogens. And we have just 1 oxygen. Okay. Oh, I think I counted wrong. That's 5 carbons. Okay. So this is going to be C4, H9, 10, and then that. 18 is 4. Sorry for that. 19, given the structural formula, formula A, B, C, D, which 2 formulas represent compounds that are isomers of each other? So again, isomers have the same content, okay? So let's just count it up. We have 2 carbons here. Let's just write C2H 1, 2, 3, 4, 5, 6, and O1. C2H 1, 2, 3, 4, 5, 6. Okay. Then oxygen is 1. So I think A and B are gonna have a thing together. So yeah. So 19 is 1. Yeah. So butanol and butanone have different chemical and physical properties, primarily because of differences in their functional groups. It's all about the functional group, which determines what the hell they're going to do. So what does it mean if 2 compounds are isomers of each other? It means they have same content but different. They have the same content. Same content, but different structures. Okay, 22. In the space provided below, draw the structural formula for an alcohol that is an isomer of diethyl ether. Okay, so diethyl ether. Look, this is a little tricky. This is going to tell us that we have 2 carbons on each side. Can you see that? Oh, oopsies. Okay, that's what it means with di. We have 2 carbons each side. And we're going to talk about an alcohol. Draw the structural formula for an alcohol. Okay. So let's just write in our hydrogens. And since we're going to show that this is going to be an isomer, basically alcohol, so we know that we have a total of 1, 2, 3, 4. We have 4 carbons. And we'll just have our OH, that's our alcohol. And this is our isomer. But let me make sure that we have the same number of hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Beautiful. Next, draw the structural formula for propanol and butanol. These molecules have similar chemical properties, and explain why. Well, similar chemical properties because they both have the same functional group. Similar properties because they both the same functional group. And the formula for propanol, let's just label it right here. Pro means 3, so we have C And butanol means 4. So these dashes I'm drawing here, they represent hydrogen because I'm too lazy to draw the H. Next, the formulas below and the boiling points at standard pressure for ethane, methane, and methanol and water are shown in the table below. Okay. So explain in terms of molecular polarity why the solubility of methanol in water is greater than the solubility of methane in water. Okay. So methanol is more, so in terms of solubility, you can just say methanol is more polar. Or, well, we can say that methanol and water are both polar, and we know that they're both polar because they have their structure is not symmetrical. So we can just say methanol and water are both polar molecules, while methane and water is nonpolar, because if we notice, methane is very symmetrical. And like dissolves like, so polar dissolves polar. Explain in terms of particle attractions whether solubility of methanol in water is greater than the solubility of methane in water. Okay, so methanol in water have stronger attractions. Towards one another. While methane has a weak attraction. Honestly, when you talk about particle attractions, it's basically just asking you which has strong and which has weak. (26) Which class or classes of organic compounds contain nitrogen in it? Okay, just refer back to table R, and which has N. Okay, we have amine and amide, and that's pretty much it. So let's just write it down. So which classes of organic compounds are capable of hydrogen bonding? Let's see. Let's see, hydrogen bonding. Well, we have pretty much everything: alcohol, organic acid. Yeah. So hydrogen bonding is basically hydrogen's bonding to OH. That's what it is. Hydrogen bonding is it's not HH, no, it's O and H. So if we refer to table R, let's see, alcohol, there's an OH right here. What else has an OH? Organic acids, yeah, that works. Okay, what else? Yeah, I think that's it. Yeah, okay. So, number 28, it says, draw a structural formula for the following molecules. Okay, diethyl ether. Let's see. We have, so it's basically telling us we have 2 carbons on both sides, and fill up this up with our hydrogens. Butanol, we have what's, butanol, this is an aldehyde, so it tells us we have 4 carbons. 1, 2, 3, 4. And on the last carbon, we're gonna have O and then H. 2-pentanone, that's a ketone. So it says on the second branch, that's where a ketone is gonna be. So C, 1, 2, 3, 4, 5, second branch, 1, 2. Our second carbon, and then we're gonna fill this all up. And then propyl pentanoate, when we see propyl, that's going to be an, okay, this is an ester, yes, label that. So, you're going to write, whoopsies, I'm sorry, I'm blanking out. D, okay. So here we're gonna have 5 carbons, 1, 2, 3, 4, 5. And then that carbon's gonna branch out. Then we're gonna have 3, 1, 2, 3. And let's put all our hydrogens. Good. Okay, now, when we're given like a paragraph or whatever, I do not read this paragraph at all. I just go straight to the question. Identify one functional group in a glycine molecule. Okay, I guess we need to read it. Glycine, NH2. Okay, we have functional group. Okay, we have COO. That is a functional group. COH. Yep. In a space below, draw a structural formula for acetamide. You know, I'll just write up here that this is organic acid. Acetamide. Okay. Acetamide gives us CH3CONH2. Okay. This is an amide. Yes. We have C, we have H. C, and then we have O, and NH2. Okay, cool. Next. Okay, given the balanced equations representing a reaction, CH3, CH2, blah, 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 this organic reaction is best classified as, okay, so we have plus Br2. I see some substitution going on, so 31 is going to be 4. Ethanoic acid and 1-butanol can react to produce water in compound classified as an, okay. So ethanoic acid and 1-butanol is going to produce an ester. Why an ester? Well, with ethanoic acid, we have COOH, and butanol, which is has COH. So when these COOH come together, we're in producing water, we're going to be left with COO and then HOH, you know. That could be a little confusing. Okay. 33. Which formula represents the product of the addition reaction between ethene and chlorine? Okay, when we see addition, it's going to turn into saturated bonds, and And we're gonna see that chlorine is also gonna be incorporated with this. So number 2 is gonna be the answer if we're starting off with 2 chlorines. 34, which type of organic reaction produces both water and carbon dioxide? That's some combustion right over there. 35, okay. This is a reaction, this reaction is an example of, okay, so, we get a result of water, and let's see, this could be, we have no idea what the hell hydrogenation is. Fermentation, that would start off with sugar. It could be saponification, not sure, but I think we would get carbon dioxide in saponification as an output, but let's just check esterification. Do we see an ester right over here? See, yeah, we do. Okay, so 35 is going to be 4. So which reaction produces an ethanol? Okay, ethanol, we're thinking alcohol, not combustion, fermentation, because we start off with sugar, and then we wind up getting an alcohol and carbon dioxide. So 36 is 3. The reaction that joins thousands of small identical molecules to form one very long molecule is called polymerization. Because polymerization, remember, poly means many, so we're having many repeats of itself. Okay. 38. Which type of reaction is represented by the equation below? No, n and n are very large numbers, to about 2,000. Okay, so this is taking double bonds, making it into single bonds. Probably, what's going to occur here is, probably it's going to be polymerization, because it says here that we're multiplying it with n. When we see an n, that's automatically going to be polymerization because we're multiplying itself by like n number of times. Okay, final page. Given the equation C2H6 plus Cl2, C2, whatever, in terms of saturated or unsaturated hydrocarbons, explain why the above reaction is substitution reaction. It is substitution because... Okay, that's nice. It gives us oh, that's different. Okay. Because C2H is a saturated hydrocarbon. With only single bonds. So it's pretty much asking you, okay, so why is, how do you know if C2H6 is saturated? So it's saturated because, well, it's basically asking you why is this substitution? It's substitution because C2H6 is a saturated hydrocarbon with only single bonds. Yeah, okay. So 40. In terms of saturated or unsaturated hydrocarbons, explain why the above reaction is an addition reaction. It's addition because we're taking an unsaturated hydrocarbon and making it saturated. Which organic reaction produces soap? Okay, so I have trouble, spelling this out, and it kind of sounds like soap. Whenever you're in trouble of like, oh, there's a vocabulary term that I don't know, go back to, multiple choice, because you're going to probably fish something out there. So the reaction example of saponification, all we just have to do is just transcribe it. Saponification. And we are all done. Smiley face.